Okay, so today we're going on to 5.1, the nth root, radicals, and rational exponents. So we're going to be working with all of those. We are no longer just with square roots. I can give you any root I want. So I can ask you a fourth root or third root or 28th root, whatever I want to do. Radicals. And then we have rational exponents. Remember, a rational number is a fraction, yes? Yep. And we will be making these exponents. Okay. So, what is the cube root of 125? So, the cube root is how many? How many is cube? 3. So we write this as the cube root. So this is a radical sign, not a square root sign. And a 3 goes right in here. Right in there. Of 125. So with a square root, you're looking for pairs of what? 2. With a cube root, you're looking for pairs of 3. Well, you all should know the cube root of 125. Because it is this it's 5, because we know 5 cubed, yes? So the cube root of 125 is 5. We'll go down.
I spelled root, R-U-T-E.
Well, that is not right. Okay, so what is the fourth root of 16? So now we're going to put a what out there?
4.
A 4.
2. Yes.
Yeah, it's 2. Because 2 times 2 is 4, right? And 4 times 4 is 16. So 2 to the 4th is 16. So how about the fourth root of 81 on your own?
How are you getting this?
So it's like...
What numbers? This is 2. This 16 is 4 times 4, yes? But I'm looking for pairs of 4. So that's not going to help me out, is it? And 4 is 2
So you would put 4
times 2 times 2 times 2.
Get you 16.
2 to the 4th is 16, yes. So the answer is 2.
Yeah, I think so.
Okay. So the fourth root of 81 is 3.
3, 9, 22.
Because 9 and 9, yes? And 3 and 3 and 3 and 3. So I have one group of 4, correct?
Are we going to go past 4?
Oh, okay.
Oh, yeah, I could ask you anything.
Please don't.
That don't sound nice.
Okay, so then I have the cube root of 64.
4. No. 4?
Is he right, guys?
Yes. I am right.
Because 4 cubed is 64, right? So these are all numbers you already know. You just have to break them down differently.
Now what's the trick here?
Can you not change it so I can...
What else are you
Hurry
going
up.
to add on?
Right.
What else are you going to add on? 'Cause I feel like
Well,
this
that's
is
just the
new.
first part.
Yeah.
So you've noticed I've been calling things radicals and the root, right? So there are parts of a radical we need to talk about because I love it when someone sees this problem right here and they say the square root of 3, 125. What? They look at this problem and that's how they say it. They say the square root of 3, 125. Or square root of 3 of 125. That's not what this says. It says what? The cube root of 125. This symbol is a radical symbol. That is a radical. Okay? So we have these things. We have the nth root. So this symbol, and I touched it and it's going to change. Sorry, guys. This symbol is a radical symbol. N is called the index. X is called the radicand. Isn't that a cool word?
No.
I think so.
You want
I think
to
it's
write
cool.
that?
If I say radicand, you better know what a radicand is.
X. I deeply decided by the next question.
It's not a question. It's a statement.
What is the meaning of the exponent? That's a question.
What is
Oh, the one with the exponent. Okay, now the next section is typed, so I will rewrite it in case it's hard to read. But a rational exponent, rational means a fraction, correct? So I have x to the 1, it is x to the 1 nth. The 1/5, the 1/8, the 1 nth, whatever. Okay, is equal to saying the nth root of x to the first. Now I'm going to take this a step further and I'm going to say x to the a over n is equal to saying the nth root of x to the, guess what? A.
Do we have to write that one?
Well, this is the general rule because the numerator isn't always going to be 1. Does that make sense? Now, when I see something with a rational exponent, the denominator tells me the root, the numerator tells me the power. Understood? So this says, what is the meaning of the exponent 16 to the 1/4? What does that mean? What root?
The 16th.
the fourth?
The 4th root. What it means is the 4th root of what? 16. Which is what? We already said it.
2.
2. Because 2 times 2, 2 times 2 times 2 times 2 is 16. And I'm looking for groups of 4. How do I know I'm looking for groups of 4?
Plus 4 is
Because it's the index, right? Correct. Well, yes, Blaine.
So if, like, the top of the fraction of the exponent, the rational exponent, if it's 1, you don't have to put anything?
Right.
Okay.
Because the degree, the power is 1. So what if I said 16 to the 3/4? Okay.
What?
So I have 16 to the 3/4. Yes?
Would be 3/2.
So, well, I'm looking for the 4th root
of 16.
of 16 cubed. Correct?
Would it just be 6? No.
Well, it can't be just 16. Now, if it was the 4th root of 16 to the 4th, then it would be 16. But let's think about this differently. Well, we said that 16 was 2 to the 4th, right? So instead of putting it in a square root, I'm going to do something with these exponents.
2.
It's 2 to the 4th to the 3/4. Because 16 is 2 to the 4th, correct? See how I just rewrote that? 16 is 2 to the 4th, correct? Now, when I have a power to a power, what do I do to those two numbers?
Add them.
Not add them,
Reduce.
multiply them. So when I have 2 to the 4th to the 3/4, I have to take 4 times 3/4,
3.
which is 3, which 2 to the 3rd is
8.
8. So 16 to the 3/4 is equal to what?
8.
8. Now, think about how we just did that. If we did this with the radical, we would have to break down 16 3 times, wouldn't we? We'd have to go 2, 2, 2, 2, that's 1. 2, 2, 2, 2, that's 2. 2, 2, 2, 2, that's what? 3? 3, right? And there's one group of 2s, 2 groups of 2, and 2 groups of 2. So that's 2 times 2 times 2, or 2 to the 3rd, or 8. Was it easier just to do with the rational exponents?
Yes.
Yes. We don't do a whole lot with rational exponents until we get to calculus. We work with them here or there. But when we get to calculus, it's an everyday, all-day thing. Rational exponents. And the sooner we get to deal with them and understand them and just deal with them, it makes everything better. But that means we have to be getting common denominators without having to be reminded of how to do it. That means we have to work with fractions, correct? Sorry. Had to break it to you. Okay, so we're going to just do some other things. We're going to try to do these simply. Okay, so we need to think about 27 and how we can break down 27 smaller.
3 to the third.
It's 3 to the third, right? So I can write it 27 to the 2/3 is equal to 3 to the third all to the what?
3 or 2
2/3.
I think it 3. Or just 2.
Because 3 times 3 to the third is 27.
That's just 2.
So then the 3's reduce, and I get 3 squared, which is 9. Think about having to put that into a radical, guys, and dealing with it. Would you rather do it this way or the radical?
This way.
This way? I would. Now, they don't all work out nice, correct?
The next one.
So
Well, the next one does. What's 1/2? Well, think of 25.
5 and 5.
5 and 5, so it's 5 squared, right? So 5 squared to the 1/2, which is what?
1.
Are you meaning 5 to the first when you say 1? Okay. Yes, Blaine.
So how did you just get, like, on the first one?
Mm-hmm.
How did you get rid of the 3?
Well, because when I take 3 times 2/3, isn't that just 2?
Yeah.
Yep. So then it becomes 3 squared, which is 9.
Oh yeah.
Cadence?
Let's say you had 36 to 1/2. Would that just be 6?
Yep, 36 to the 1/2. Now, when you see anything to the 1/2, you should be able to go square root. Square root. So 36 to the 1/2 is 6. 49 to the 1/2 is 7.
So if we seem like that, we could just put 5.
Yes.
Awesome.
As long as when you see 1/2, you should see square root. When I see 1/3, I see cube root. The more you work with these, you're going to see it and say 4th root, 5th root. Now, after you get about 4th root, you got to take some more time to think about them. But you should be able to do most square and cube roots, correct? Now, there will be some times where we have things that you can't, like 12. If I had 12 to the 1/2. Okay? I can't do it with 12, but I have 2 squared, yes, times what? 3?
Yeah.
Isn't that 12? Okay, so when I have it like this, I distribute that to both, correct? So I have 2 times 1/2 is 1. So I have 2 to the first, and I would have times 3 to the 1/2, right?
Yeah.
Well, 1/2 is what? The square root. So I just put it back in a
Oh.
square root. So you can simplify radicals with the same method. And it actually, to me, is easier to do. Because I don't have to be worrying about all these radicals running around. Okay, so I have 32 to the 2/5. How about you guys try that one on your own? So you got to figure out what 32 breaks down to. Your numbers today are going to be nice. I'll promise you that.
I hope so.
They better be.
Is it just more examples like this?
Yes, it is.
No.
Is there like more added onto it?
I can't even do this example.
Break it down. Make your factor tree for 32. What times what is 32? And keep breaking it down.
9, 8. Nothing times 9 is 30. It's 8 and 4.
And then keep breaking it down.
Brother, that's not how that works.
She's
Like,
getting
it
there.
has to be this.
No, she's fine. 8 and 4. Then she needs to break those down again.
2 and 4.
And again.
2 and 2.
And 2 and 2 and 2. So it's 2 to the
4.
5th. 2 to the 4th, we went over a couple times at 16.
I love factor trees.
Okay, you will start knowing your powers of 2, guys. Knowing your powers of 2 is extremely helpful. Okay, so now the 5's reduced and I get 2 what? Squared, which is 4. Now I'm going to blow your mind, guys. And I'm going to go back and I'm going to say your answer to 25 to the 1/2 is really plus or minus 5. And I'm going to come back to 36 to the 1/2 is really plus or minus 6.
Why?
The square root.
And I'm going to take this and say plus or minus.
The square root.
Because it could be negative.
And I'm going to say 16 to the 1/4 is really plus or minus 2.
So all is plus or minus.
Not all of them.
The even one.
The even ones. Why?
Because math is weird.
Because.
No.
Because it
That
could be
is
2
true.
negatives.
Because an even number of negatives is a positive, correct?
Yep.
Yes? So anytime you have an even root or an even index, your answer is going to have how many solutions?
2.
2. So even roots,
An even denominator.
yes, but that would be, that would be the root. Okay? Even roots have how many? 2 solutions.
That's fun. I don't really know that.
Okay? Now, odd roots are not going to have 2 because unless there's a negative there, it's a what? Positive. If I threw a negative there, the answer wouldn't be negative, a positive 9, it would be what? Negative 9. That's really easy with odd ones, right? But all even roots have how many solutions? 2.
I need my highlighter for this.
What's next?
I'm waiting.
You really want to see what's next?
No.
You're so excited you can't wait.
Is
I
it-
think we stopped.
Okay,
is
we're
it
good?
difficulty?
Yeah.
Okay. So,
Oh.
evaluate. So that means just do it, right?
Did the first one.
Factor trees.
We just did the first.
Oh, we just did the first one? I think we were probably supposed to rewrite the other ones. So don't worry about the first one if we just did it. I bet the other ones we were supposed to do like,
The first one,
Oh, I didn't like what I saw there.
and 2/5.
It was 3/5.
No, it was 2/5.
No, it was 2/5.
I think it was 3.
Oh, those,
it was 2/5
this was 3/5.
and this one's 3/5. Okay, so we didn't just do it. Okay, I think the other ones they wanted to write them in radicals, but we know the bottom is the root, the top's the power, right? We know that. Okay, so we already know that 32 is 2 to the what?
8.
8.
No, that's the answer.
No,
8
32 is 2 to the what?
Fifth.
5th. So 2 to the 5th
Times 3/5.
times 3/5
Was 2 to the 3rd.
is 2 to the 3rd.
It was
8.
8. Why is this one not plus or minus?
Because it's
Because it has a
3/5 and
negative
not.
for the
How do you get
top.
8?
Okay, the denominator's odd.
Do you add 5 and 3 together to get 8?
No. You're a power to a power, you multiply. So when you have 5 times 3/5, the 5's reduced and you're left with 3. And 2 times 2 times 2 is 8. Because cubed means multiplying times itself 3 times. Okay, 50.
We do 5 squared times 2.
Okay, so 50 is 25 times 2, yes? Yeah? So we have 5 squared for 25 times 2, all to the what?
3/4.
3/4.
Oh, well, that's.
Cancel out the 2 and 4.
Does anything come out of there?
Can you reduce the 2 from the 4?
You can, but how do I want to say it? Okay, we're going to do it this way. Let's distribute this in. Got it? Okay, so we get 5 to the 3 halves.
3/4.
And actually, I'm going to do 6/4 for a reason here. Okay? Because 2 times 3 is 6, yes? I just didn't reduce. And normally I say reduce, reduce, reduce. This time I'm going to say don't reduce because does the 2 reduce?
No.
No. And if I reduce the first one, I'd be working with the square root and the fourth root. And I don't want to be working with 2 different roots. Do you guys? No. We want to stay with 1 root. Got it?
Yep.
Okay. So if I separate this right here, could I separate it as 5 to the 4/4 and 5 to the 2/4?
Yeah.
I could do that, right?
Yeah.
Okay. And then I have 2 to the 3/4.
I'm so lost.
Okay, what I'm separating this fraction is 4 plus 2, 6.
Yep.
Yes. Why did I separate it the way I did? What's 4 over 4 equal?
1.
1. Right?
Yep. And then
So that means this can come out of the radical, can't it?
Yeah.
Can these two come out of the radical?
No.
No, they cannot come out of the radical because I have just 2 out of 4, don't I? I need how many? 4, and I only have how many? 2. See that? I need a set of 4, and I only have how many? 2. I need a set of 4 twos, excuse me, but how many do I have? 3. So this can come out of the radical, and it's an even, so what do I have to put in front of it? Plus or minus 5. Now, can this 5 squared come out? No, because I'm looking for sets of what? 4. And I only have what? 2. So I have this, not the square root, but the
Radical.
4th root. And I have 5 squared, so it's
2, 10, 25.
25 times. Well, and I have the 4th root. I took care of the 4th root, right?
5.
And I have 2 to the
Oh.
3rd, which is 8. So I probably can't leave it 25 times 8, can I?
No.
So plus or minus 5, the 4th root. Well, 8/4 is $2, right?
Yeah.
Now, you would think, oh, I could find some 4th roots in 200, wouldn't you? Right? Because it's such a big number.
Yeah.
But we know that 200 is 5 times 5 times 2 times 2 times 2. Are there a set of 4 of anything? No. We're thinking, oh, we can find sets of 4 in there because we're thinking square roots. Square roots we have, right? But do we have 4th roots? No. So when we could have reduced up here, we didn't because of the fact is you want to stay with 1 root. This is about the hardest it's going to get. Okay? So now let's look at this one. Well, what do negative exponents do?
They reciprocate.
They reciprocate, right? So this is really 1 over 27. Ooh, let's break down 27. 27 is what to what power?
3.
3 and 3 and 3, right? It's 3 cubed, right? So it's 1 over 3 to the 3rd to what power? 2/3? Okay, so 2/3 of 3 is just what? 2. So it's 1 over 3 squared, and I don't know why I'm going sideways, which is 1 over 9. So negative exponents, good job, Cadence, remembering it reciprocates it, right?
So since
I'm
it
lost.
reciprocates, we
So we put 1 over it. Because right now it's it over 1, correct?
so it kind of flips. Kinda
That's
like
what
when we were
reciprocates mean?
Doing the division.
Yep. Okay,
Okay.
Matt?
I remember what you said.
Next, reciprocating.
I don't know.
So is the answer 1/9?
Yep. Okay. So now the next one, the negative isn't on the exponent, it's just out there, correct? So now it's outside the parentheses, so my answer is going to be what when I'm done? Negative. Now I have an even root, so my answer would be plus or minus, but this one just told me it's what?
Minus.
Minus.
Yeah.
Okay? But I'm going to show you something. It's fun. Okay, minus. 16 is what? 2 to the 4th. So I have 2 to the 4th to the 3/4.
You can actually smart negative know when to put parentheses in.
Well, you can put parentheses, they're the same thing. I just like brackets, parentheses. Okay, so 4 times 3/4 is, so 2 to the 3rd.
Negative.
Oh, this is plus or minus 2 to the 3rd, yes?
Yeah.
Yeah.
So I have negative plus or minus 8. Now, I'm pretty sure the book says the answer is negative, but I just said it's negative plus or minus 8. So wouldn't that be minus plus 8?
Yeah.
What's a negative times a positive?
Negative.
A negative. See how the plus turned into a negative?
Just the
What's a negative times a negative?
positive.
A positive. So it went from a positive negative to a negative positive.
So,
Technically, this is the answer, but I'm pretty sure your book says this is the answer.
so the root is the denominator?
Mm-hmm.
Okay.
Root's always the denominator. Okay? I'm going to tell you, I'm pretty sure your book says this. But technically, it is this. Why is it technically this?
Because if you distribute.
If you distribute that negative.
Is that it?
So you want us to write answers like that?
hmm I will accept this. I would not accept a positive. I will accept either one of these answers, but if you tell me your answer is 8, it is wrong. Got
Do you
me?
accept plus minus still?
Yeah.
So just put plus or minus on everything.
Oh, no.
No.
Because any odd root would not be plus or minus. The 3rd root, the 5th root, the 7th root. Yeah, don't be putting plus or minus on everything. Okay, now what if I was doing an application problem and I was talking about area? I'd take the square root, right? And technically the answer would be plus or minus. But can you have a negative length? No. So the answer would only be the positive. So is that something to remember when you go into application problems? Yeah. Technically, I would tell you probably 90% of the time if somebody asks you the domain of a problem and it's not a fraction, your best bet is all real numbers until they put it into an application problem. Story problem. Real life. Because you can't have negative money, you can't have negative area, you can't have negative length.
I mean, you can, you just have to pay up.
Right, but you
So it's
still
negative.
you can't like when you're calculating profit, you can't have negative profit. It's not profit. The profit's 0 then. Make sense? You're losing money, but that's not a profit. So it's different words. Yep. Okay, so now we're going to do this, which is not in rational, but guess what we're going to put them in? Rational. Okay, so everything is going to be what power? To what power?
5.
Not 5. The
5.
1/5, the 5th. Okay, so we're all going to put it to the 5th power, right? So 32. What's that?
8 and 4, which is 2 and 2 and 2 and 2 and 2. 2 to 5.
It's 2 to the 5th. I was hoping by now you could just tell me it's 2 to the 5th. Okay, and m is just m to the 15th, right?
Yeah.
Yep. So if you remember your exponent rules, we have to distribute this in, don't we?
What, it gets 1 and
So I get 1/5 of 5 is what? 1. So that's 2 to the 1st, right? And then 1/5 of 15 is
The third.
3rd. So did I have any leftovers? No, because 5 went into both of those numbers evenly. If I had any leftovers, they'd be still in the 5th root, wouldn't they?
So that's the answer.
That's the answer.
Isn't hard.
No, it's not. Is it going to take you a second and you have to slow down a little bit? Yeah.
I don't like the
These,
last
not the other
problem.
ones.
It's easy. Okay,
I don't.
so it's a cube root, yes. So can we take cube roots and 7th roots and 17th roots of negative numbers?
Yeah.
Yeah. So my answer is going to be what? Negative. Whatever it is, it's going to be negative, isn't it? Okay, so let's break it down now. So everything to what power?
4.
Not 4.
Third.
The third. So 2, I just gave away. 8 is 2 to the third, A to the third, and B to the ninth. And just distribute it to each one. Because, guys, this is negative 2 to the third, so that's negative 2, negative 2, negative 2, right? Let me do that so you can see it. So, negative 2 to the third to the 1/3 is just negative.
Just 2AB.
Yep. Negative 2, and then 1/3 of 3 is
1.
1, so A to the first.
1.
Nope. Not for B.
Why?
How many times does 3 go to 9? 3.
That down is 3.
Wouldn't A be to the third?
Nope, because 1/3 of 3 is 1.
Why do you have a
3
one?
times 1/3 equals 1.
You don't need the 1, but it.
I just wrote it to see it. You don't need it. Okay, and she just wrote it down wrong. Is that what you said? Okay.
I'm sure it's right on the page.
Okay, so the next one. Oh, we don't have any numbers. That makes it even easier, doesn't it?
Yep.
So x to the 20th, y to the 8th, all to what power?
1 and 4.
To the 1/4. So we distribute our 1/4. So we're dividing 20 by 4 and we get what?
5.
5. 8 by 4 we get
2.
2. Now, guys, if they were leftovers, they would have to stay in the 5th root, correct? What I mean by leftovers is a remainder. What if I had y to the 10th?
You can't simplify?
If I had y to the 10th to the 1/4, how many times does 4 go to 10?
Twice.
Twice. So I could bring out y squared, but I would still have the 4th root of y what? What's the remainder? 2. See that? Layden,
Yeah,
focus.
alright.
Do you understand what I just did?
Yeah.
You didn't even pay attention. You didn't even know what I just did. Okay. So
Explain it.
this right here, you understand that this y squared is the leftovers after I divided, right? The remainder. I should use technical term, not the leftovers. No, this was a separate example. Okay. So if it doesn't go in evenly, whatever remainder stays in. Got it?
Yeah.
Okay, now 256. You guys should know 256.
I don't think we
To
do.
It's
Yep.
4 to 12.
no, it's something to the 4th.
No. Well, it may be something to the 4th, but it's one of your squares and cubes.
Oh.
Those things? Forgot about
14
those.
times 14.
No, that's
Like
196.
21 or something.
It's not 13, it's not
24
14.
maybe?
It's not. Is it?
It's
15.
25. Never mind. Isn't it
Okay, so we don't know. We should.
16?
Okay, let's break it down. What do you want to put into it? What do you want to put into it?
14 is 196.
What do you guys want to break it down? 256. Break it down.
Um,
At least.
2.
Do you want to go a little bigger than 2?
No.
Maybe-
I always do it by 2 first.
4.
I know 4 goes in there.
Yeah, but that's just
let's
2
do
and 2.
16.
Okay, so that makes the other one easier. So that's 6 and 4. So now it should be really easy because 4 is 2 to the,
2 and 2,
and 64
and
is 8 times 8 is 8 times 8, but 2 is 8 cubed, right? 64 is 8 times 8, correct? But 8 is 2 cubed. So 2 cubed and 2 cubed would be 2 to the,
16.
how about 6?
What? I do not mean that.
Okay, so it's 2 to the what?
6.
6th, and 2 to the 2nd is 2 to the,
Oh, 6 times I forgot you.
you add exponents when you multiply, correct?
I forgot.
Starting black hole.
Maybe my brain's frozen.
Maybe. Okay, now what am I gonna do? I'm gonna distribute my 1/4, correct?
Yeah.
Am I gonna have any remainders?
No.
Nope. So it's gonna be 2 to the
Second.
2nd
X to the third. Y to the sixth.
and 2 to the 2nd is 4. 16 squared, guys, is 256.
Someone said that.
Well, someone guessed that.
No, I got it right on my test in geometry.
Okay, but this instant you guessed it. And I wasn't going to answer you because nobody was like, oh, yeah, you're right. Okay, so should we remember our squares and cubes? Would it have helped us?
No,
I'm
not
never
at
gonna
all.
remember that till the day. I
When
die.
did we do squares?
Geometry.
Yeah.
All year last year?
Not all year,
I
Miss
thought-
May.
Okay, well, then I'll start doing them once a
No,
week.
no,
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 never.
no.
Well, you, Matt said he didn't have enough of them.
No, I never said that.
Okay, I'm going to tell you right now, guys, if you know your 1 to 25 and your 1 to 10, it does help because that's what they use on standardized tests. That's what I use. If you know those things, it does help you. Just to let you know.
Please tell me that's it.
I know 1 through 10 on squares.
Whoa, what is this?
Okay, no, do you stop? Okay, I have 2x to the 5th equals 64. So, obviously I'm solving for x, right?
You make me waste so much paper. Divide by 2.
Divide by 2. How did you know, Cadence, to divide by 2?
The coefficient in front of X is 2.
Yeah, coefficient, because that's how we solve an algebraic problem, right?
What?
X
So we divide by 2. Divide by 2. Divide by 2. So x to the 5th
Equals 32.
equals 32.
It's 2.
It is 2, but we got to figure this out. Okay, there's a couple ways we can do this. We could take the 5th root of both sides, yes?
Yeah.
Okay, because if you're taking something to the 5th power, opposite of that would be the 5th root, correct? Or you could just break down 32 and say, well, 32 is 2 to the 5th, right?
X to the
And if x to the 5th is 2 to the 5th, that means x has to be what?
Have messages in the office.
2.
Just come to the office when the bell rings.
But again, the
Brandon
other way we could have
Carmichael,
done it
Braden Weiner.
is to take the 5th root of both sides, right?
I don't want to do that.
Reminder for
It's the same thing.
students
Same
to
thing.
sign up in the office if you're going to need
Okay, so
transportation.
2p to the 4th equals
On
162.
March 16th, please stop in the office to do that.
Divide by 2.
Next year's registrations form.
So
be sure
p
you
to
get
the
those
4th
completed and turned in
equals
by Friday.
81. So you take it to the
Scholarships for seniors.
fourth
be sure you're
root.
Checking that out. in group
And yes,
classrooms.
you're right, Cadence. But Cadence says she knows that 81 is 3 to the 4th.
March 1st, so you need to get those done.
So what does that make
Here's
p?
some pictures for
Three.
FBLA members today. Please report to your IAP. And then.
So you guys try the last one on your own.
In the auditorium.
So 5x cubed equals 320.
Right.
Once you report to your IAP, you then need to report to the auditorium and go to the seating area. Hopefully you have your shirts for that. If you're Mrs. McKinney's IAP, please check the door today.
You guys ready for me to start?
Changes on where you go for IAP today. Mrs. Sluter's IAP goes to Mrs. Baumgartner's room. And tomorrow for National FFA Week, it's
Is that 4 minutes?
Carhartt Day. Wear your Carhartt attire.
Why are the hardest looking ones not the easiest ones?
Questions?
No.
Okay, we're working on it.
X equals 3?
Yes?
4.
No? Oh, yes, it should be 4. Thank you.
I was gonna say.
Thank you. Thank you. Okay, so you're starting today on them, and then we're working again tomorrow on them. So I expect you guys, everyone, to have their homework done tomorrow. So when I ask for questions, I get legitimate questions, not the look, I didn't do my homework, so I can't ask you a question. Because that is why we had the test grades I just put in the grade book.
Why are you like staring at me when you said that?
Because
Like I felt like